Hi, I'm Likit. We'll be discussing about the new subject, file structures. In that, we'll be mainly focusing on one topic. Beyond the leaves, exploring multiple multi-level indexing with B-tree. So I'm I'm from Information Science and Engineering Department. So we'll go into the topic right now. So these are the contents we'll be discussing in this video. Introduction, what is multi-level indexing, why we use B-trees, how B-trees work, advantages of multi-level indexing with B-trees, conclusion. After conclusion, we'll be discussing the working part, how actually practically B-tree works. I will show you in the practical way. If we go to the introduction part, have you ever wondered how large databases can perform searches so quickly? The answer lies in multi-level indexing with B-trees. By using this technique, databases can efficiently organize and retrieve vast amounts of data, making it possible for us to access information in the blink of an eye. Multi-level, what is multi-level indexing? If we go to the definition part, multi-level indexing is a technique used in databases to improve query performance. It involves creating an index structure that consists of multiple levels, with each level containing pointers to the next level of the index. There are two types of trees which will go under the multi-level indexing that will be discussed on the working part, but I will be till the basics about what are the types B tree and B plus tree. If we go further on under the definition, this idea behind multi-level indexing is to reduce the number of disk access required to retrieve data from a database. By using a hierarchical structure, queries can be answered more quickly and efficiently. For example, if you have a large database with millions of records, a single level index may not be sufficient to provide fast access to the data. However, by using a multi-level index, you can break the index down into smaller pieces, making it easier to search and retrieve the data you need. So, after by knowing the definition, we'll be thinking that why we use this B trees in the real time or any companies where what at what time these B trees will be used. So if you go to that, B trees are a type of self-balancing tree that can efficiently store and retrieve large amounts of data. One of the key benefits of using B trees for multi-level indexing is their ability to handle large data sets without sacrificing performance. So if user can't accept the performance delay, or he can't compromise with the delay in the efficiency of the work. So if we use the B trees, the that level may be reached by not compromising having the infrastructure up to the mark. This is because B tree have a logarithmic time complexity for most operations, which means that they can quickly locate and retrieve data from very large data sets. Another benefit of using B trees for multi-level indexing is their scalability. B trees can be easily expanded or contracted as needed, making them ideal for use in applications that require dynamic indexing. Additionally, B trees are often used in database systems because they can be optimized for specific types of queries, such as range queries or point queries. We go to the next content of B tree, how B tree works in a theoretical manner. B trees are balanced tree data structures that are commonly used for indexing in databases and file systems. They are designed to efficiently store and retrieve large amounts of data from disk or memory. The key feature of B trees that have multiple levels of nodes, which allows them to minimize the number of disk access required to find a specific piece of data. At the top level of B tree, there is a single root node that contains pointers to other nodes. Each subsequent level contains more nodes, with each node containing a range of keys and pointers to child nodes. The leaf nodes at a bottom level contain the actual data values and pointers to their corresponding records. By dividing the data into smaller chunks and storing it in different nodes, B-trees can reduce the amount of disk input or output needed to access the data, making them ideal for large-scale databases and file systems. So, by seeing this theoretical explanation, we can't understand how it works. I will show you in the better way by drawing and explaining it. Uh, Prior that, we'll be going to the next topic. So by listening all this matter, we'll be thinking that what are the advantages of having these uh, things by getting the multi-level indexing. One of the major advantages of using multi-level indexing with B-trees is improved performance by breaking down large indexes into smaller, more manageable pieces. B-trees can speed up search operations and reduce the amount of time it takes to retrieve data. Another advantage of multi-level indexing with B-trees is scalability. As data volume grows, traditional indexing methods can become less efficient and more difficult to manage. B-trees, on the other hand, are designed to handle large amounts of data and can be easily adapted to accommodate changing needs. So we'll be, as I promised, we'll be going to the working part, how it works in practical way. Not a practical way, but I will be explaining better than the theory explanation. You will get to know that how B-tree works. Before going to the working part of B-tree, I will be giving an example of having a data information which is stored in a database. By using B-tree, how it can be comprise the data into a smaller pieces and into the small chunks of data. So here we given the details of students having the marks scored in the three columns: USN name and marks, defining all the students USN and names and marks corresponding to them, which have their score, and we will be dividing this data into small chunks of data like 001 and 002 as a one block. Each element in this block called as a record. 001 person 180 is a record. Like that, up to 007, each there are 7 records in this table. So we'll be dividing into small chunks of data or blocks. We'll be dividing into 4 parts: 001 and 002 as one block, 003 004 as second block, 005 006 as third block, and 007 alone as a fourth block. So we'll be in B-tree. Actually, we'll be doing the searching method. So if we want to search 001, there will be a data stored in this block of containing 001 002. Rather than searching each and every element in the table, we can be using the nearest part of means 001 002. So it may be containing our required element. So we'll be using small methods and we'll be finding the element very fast. So the in search block 001 is needed. It is containing in this block 003 is needed. 003 and 004 stored in this. Like that, the here two blocks are stored and these index values are required. And here the another two blocks are stored. So it is a single index. By having, if what is the meaning of multiple indexing means having multiple single indexes in an index. Like these single indexes will store in the multi-level indexing table. In this index, a column will be there and pointer column will be there. These pointer columns will be focusing on the index table pointer. Index table 1 and index table 2 will be storing in this multi-level index table, and it it will be giving some address by using the index value. So we'll go into the working part of B tree. So in B tree there are actually there are two types of trees which will undergo multi-level indexing. They are B tree and B plus tree. Tree pointer points to the internal. Actually, there are two pointers in these trees called uh, tree pointer. This is called a tree pointer. This is called the tree pointer, and this is called a data pointer. Tree by based on the number of tree pointers, we'll be getting to know that the order of the tree. And in this B tree, there is a rule that root is greater than the left node, and root is smaller or equals to the right node. So we'll be following that rule and forming the example. Here 9 and 14 is there. So in the left node, it is lesser than the 9, lesser than the root node 3 and 6. In the center node, 11 and 13 greater than the 9. So in this right node, it is a null node. So these are the leaf nodes. Actually, a B tree consists of pointers, values of pointers, and record numbers. It will be ending up to how many uh, orders, means n is equals to order. Up to the order of B tree, it will be stored that many values of pointers and record numbers. So there is another tree called B plus tree. We'll be discussing in the future videos. Thank you for subscribing and viewing my channel.